Okay, now what we have done is we saw that virtual inheritance was one way of resolving the diamond problem, which we did in the earlier video. But now we are not relying on virtual inheritance because that's not really very reliable. It's more of a compromise rather than a solution to the diamond problem. Now, here, what we are doing is that we've got two interfaces from which we had C Mobile inherited. But now, since that is not allowed, what we'll do is that iCalculator will keep it independent. We'll inherit C Mobile only from iMobile. And for the iCalculator, we'll have an independent class, which is called as tie underscore iCalculator. So we'll give the name of the class exactly as this. That's what I would request readers to do, that you name the class as tie and you'll have the implementation of calculator here. Now you want a component. Now we'll start calling it as a component because it's no longer a class. We're going to have two classes now, C Mobile and tie calculator. Together they'll serve our purpose. It's like two people coming together. Like I may not know everything. And for this training, for instance, I'm training you on the Innovia or maybe on CATIA CA, but C++ training was done by another faculty. Both of us coming together, can you train you on the entire product? So the faculty takes the external faculty will do the C++ training while I'll do the product training. And that's how these two classes, they would work in coordination, which means C Mobile will have the pointer of tie calculator with it, and tie calculator will have the pointer of C Mobile in it. So whenever you are working with the mobile, you'll be able to call, make call, and receive call. And when I say that, okay, do a query interface, now let me work with the calculator. The query interface will return the pointer of the calculator. Either it is stored in it, or to begin with, it may be a null pointer. It would create it. And while it is being created, you may have a parameterized constructor wherein this mobile will be passed on to it. This and that would be stored in the calculator. So the calculator would have the mobile in it. So the calculator pointer you would call add and subtract. And from calculator, if you want to do a query interface, then calculator would already have the mobile in it. So that's how we are going to have two classes working in coordination. So the core essence of it is that we'll create two classes, C Mobile inherited from iMobile and tie calculator inherited from iCalculator. We'll have them data members to it as tie calculator for the C Mobile. And in the tie calculator, we'll have the C Mobile pointer. And we'll have the implementation in each of these classes. So if I just go to the shared library, I don't really have to do anything in the interface library now. But in the shared library, let me just see what have I done with cmobile.h here. Okay, so I have got rid of this multiple inheritance. You see, I've commented it out. And this will solely contain iMobile. It contains the pointer of the calculator class. And because it has the calculator class and then nothing much, it's the same thing. We have a release being overridden here. We'll come to that a little later. But otherwise, this is what it's going to have. And for the you have forward declared tie calculator because if you notice, this could be cyclic. So if I just say C Mobile has a reference to tie calculator. So if you hash include tie calculator header here, then tie calculator header would have the mobile in it. So it would hash include mobile, which means this whole thing now gets into a cyclic loop. And that's the reason you should not be hash including your calculator here. You can just forward declare it. So forward declarations won't put it into a cyclic loop. Okay. The hash include you could do it in cmobile.cpp, and I think that's where they've done it. So here they've done a hash include of the tie calculator. Now let's come back to our C Mobile. And we have said that it would have the implementation of make call and receive call. The add and subtract, I have commented it out. That's not needed. And when the factory creates it, it would create the mobile. And then if you want to work with the calculator, you would have to do a query interface for it, which is the same. And if you want the mobile pointer, you could simply cast it and return it. And mobile would do an address, which is for the time being, let's assume that it's inherited from the base class. And if it requires a calculator, this is where they work in coordination. So if it requires the calculator and if the calculator pointer already exists, then it would just be cast and returned. But if it doesn't exist, then you'll have to create a new one. So query interface actually creates a new calculator class and returns it. So this is how the calculator will be created. Okay, so that's what the code is. And then at the end, we are going to address the calculator. So address would be inherited from, let's say for the moment, from cat base unknown, and that would be from C unknown, and it would be called. So this is how the calculator class will be created. Okay. And since our primary class, so the entire component, which is the mobile and the calculator, how will they be created? You'll have to, from the factory, create the mobile class. And from the mobile, you do a query interface for it. Now, to begin with, you know that if I come back to the factory class, you know that in the factory class, you may ask for the mobile object. And this is where you ask for it and you return the mobile. So it would always return iMobile star. And in the console application, what do? From the factory, you create this, you get the mobile class, and then you do a query interface for the calculator. Which means that when you create the mobile class, if I come back here for one scenario, this would work fine. It would, in fact, create the mobile class, and then when you do a query interface, it would create the calculator and return it to you. And this would work fine, okay? Default is around choice, and that's how the query interface works, okay? There could be another case where you may want to start working with calculator, which we will not see now. But this seems good to me. And what happens on the calculator front? On the calculator, I have the implementation of add and subtract. And from the calculator, I may ask for the mobile or for the calculator again, right? So if you ask for the mobile, the calculator has the mobile in it. If it has the mobile, it will just cast it. If it doesn't have the mobile, we just say that that's an invalid case. Because TIE calculator is created by QI on C mobile. I mean, the TIE calculator cannot exist in isolation. It has to exist with the mobile class because the mobile class is the key one, first one, right? Calculator is just complementing it. So we should have it. There could be a case where you ask for the calculator class to start with. We'll see that how to handle that. For that, the factory code will have to be slightly changed. Because today the factory code is only saying create mobile object, as you saw here, and it returns iMobile. But what if I want iCalculator to start with? Then again, you need to have that switch case statement. We'll do that enhancement a little later. But for the moment, yeah, this seems good to me. For the calculator, you may ask for the mobile, and if you ask for the calculator, it is just cast and returned. And then for the calculator, when you do this, and if you are saying that, okay, mobile, if you're asking for the mobile, you would have to do an address on the mobile. If you're asking for the calculator, you'll have to do the address on the calculator. So I think this will have to be changed.